asked you guys to graph this. Class, what family is this? Number 1. Okay, so it's not quadratic because I don't have a power of 2. It is linear because it's a power of 1. Okay? To graph this, super simple might be y equals mx plus b. Raise your hand if you've heard of that before. Okay? What does it tell us? This b is the y-intercept, or the beginning, where you start. Put your finger at 2 on the y-axis. Let's color code it. Right there. The m represents the... You tell me. The slope. What's the number there? 0. There's nothing, but there is a number. What is it? 1. Okay, make the 1 a fraction. 1 over 1. Why did I do that? What's the phrase you guys know about slope? Rise over run. It's saying start at this point, you're going to rise of 1 and run of 1. Going up 1, right 1. Up 1, right 1. Okay, I'm going to do that in pencil. And I have graphed a line. Okay, let's just say you want to go the other way, okay? This would be left 1, down 1. Negative 1, negative 1. Do you see that? Because negative 1 divided by negative 1 gives you a positive 1. And you have now graphed a line. Okay, what does the inequality tell us? The inequality tells us, put your finger at x equals negative 1. Put your pencil down. Where are x values smaller than or equal to negative 1? Left or the right? Okay, so I'm going to, watch what I'm going to do. At negative 1, I'm going to see where my pencil kind of crossed the graph right here. And I'm going to put a closed circle. Why closed? Because it's equals to. And the next thing you guys said, numbers are smaller than, so you said it's to the what? To the left. So I'm only going to color in anything to the left of the graph. Here in blue, this is what the graph looks like. Raise your hand if you at least got the line. Good. Raise your hand if you got that in blue. Okay. Good job. Let's go on to something more fun. Let's try this one now. Class, what's an easier way of saying f of x? Y. Oh. I don't know why this was like the hardest problem ever when I was growing up, but it's telling you if you make a table of values, these are my x values, these are my y values. It's telling you that all of your y values are 1. You're saying, where are the x values? What do? You can make them up. Negative 1, 0, 1. Now I just graph it. Negative 1, 1. 0, 1. Right 1, up 1. What do we have, class? You have a horizontal line. It has a slope of 0. Okay. Put your finger at the inequality now. At x equals negative 1. Open or close? This one was closed, right? So this is going to be an open circle at negative 1. Here's x equals negative 1. You put your pencil down. That's where it crosses the graph. You're going to put an open circle. Go over here. You have a... Don't worry about the inequality. At 1, you have a open or closed circle? Open circle. I'm going to shade x is less than 1. Which direction? Numbers that are smaller than 1 are like 0, negative 1, right? So you're going to the left. Okay. This one's a little bit confusing. So that's a compound inequality. If you can't read it, you're actually reading right to left on this problem. Okay. Let's just say you can't read right to left. You're just stuck in English mode. Okay. It's pointing towards the negative 1. Do you see that? Pointing towards the -1. So you read that as x is greater than -1. At -1, numbers that are greater are going toward the right. So this one's going to the right, this one's going to the left. So your graph looks like this. Raise your hand if you got the one in pencil. Raise your hand if you got the one in red. Okay. A lot of new stuff. That's okay. That's why I'm here. All right. Green one. What is it? Quadratic. Okay, let's graph the quadratic. Someone asked me a really good question. Mr. Ng, can I use a table of values? That's a great question because you're like, I don't know where to start. At least you can get some values. What would happen if you put in 0? What do you get? What happens if you put in -1? How about -2? +4, right? How about if you put in 1? 1 squared. 1 times 1? 2 squared. 4. Oh, you could have used your graphing calculator and used the table mode, right? So if I graph this, I got -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Should I make a V or a U? U. You make a V, you're going to be in big trouble. You just learned that. That's absolute value. Okay, put your finger, where do you think the green graph's going to be? What do you think the green graph's going to be? Show your partner. Give him a head nod. I go to 1. I put my pen down. Here is 1. Class, open or close? Open. Close. Remember, it's equals to. You include it. Okay, left or right? Where numbers are bigger than 1? To the right. Alright, I'm going to pause the video here and let you guys discuss these three for about 30 seconds. Okay? Help each other understand those. Ready, set, go. Alright, I didn't trick you, but I was telling a student an analogy. Yesterday the new iPhones came out. What is the future? People actually buy the phone, so they're first in lines, and guess what they do with the new phone? They break it. Why do they break it? They want to know what parts are in there. They want to be the first to be able to make the cases. Does that make sense? So if you watch on YouTube, iPhone 11 breakdown, they'll tell you how much it costs, what the parts are, and they want to be the first ones to offer the new lenses, the new rubber cases. So yours is the first on Amazon, and then you're going to sell your products. Does that make sense? So, why did I mention parts? I kind of tricked you, but I didn't. You graphed 3 different functions separately, but now you're going to put them together, and they call these piecewise functions. Everyone say piecewise functions. They're just different pieces. So look how I'm writing this now. And my green one was x squared, comma or colon, semicolon. Okay, so what do we do? You're actually going to graph, instead of graphing them 3 separately, you're going to be graphing them together. Okay, so let's put this graph on here. I recommend doing pencil first and then going back in your color. So we graphed a line at 2. It has a positive slope, and it's starting, the inequality is at -1. It's an open, oops, I messed up there. It is a closed circle, and my graph's going to look like this. So what am I doing? I'm just putting all of the puzzle pieces together. I have a graph here at -1, -1, 1, and actually that's the same coordinate. Okay? So what I'm going to do for us visually is I'm just going to put an open circle around it. But to us from very far away, what does it look like? An open or closed circle? Closed circle. And then I'm going to graph the green one. The green one was at 1, 1. It is a closed circle, so again I'm going to leave that red one kind of open. And then we said 2, 4, and then my graph should look something like this. Wow, look at that thing. Your mom and your dad get married, right? And then they do math together, and then they have kids. And you look like a variation of them. So what are some steps? How would you graph piecewise functions? How to graph piecewise functions. You guys got the graph down? Yes. Okay, how to graph piecewise functions. Number 1, everyone say boundary. Highlight, I'm going to write faster in my messy writing. Highlight the boundary by looking at the restrictions in the domain. Boundary. Highlight the boundary by looking at the restrictions in the domain. Okay, what does that mean? If I go back up to the blue graph, let's just say I'm asked to kind of graph this by myself, like without the 3 separate pieces. I would look at this number, and at -1, I would put this line down here. Everyone say boundary. This helps separates the left and right side, the boundary. It is not an asymptote. Class, what is it not? It's not an asymptote. It's just a boundary, okay? Or if I go to this one up here, you have this boundary already at -1, and then you have another one at 1. Do you see it? Okay? Second step. Everyone say graph. I want you to graph it using a pencil. Why do you think we need a pencil? Because we're eventually going to erase something that looks like that. Do you see it? Do you see how I didn't take the whole graph and put it there? We're eventually just going to graph the whole thing and then just erase it. Does that make sense? Number 3. So we got a boundary, we got a graph. We're going to erase. Erase based on the restrictions of the domain. Erase based on the restrictions of the domain. What does that mean? So, in x plus 2, you had the whole graph here, right? And this says x is less than -1. So we knew those were numbers to the left. So what do? You're going to take your pencil and you're going to erase everything over here. I want numbers that are smaller than -1, so that graph stays. And then step number 4, evaluate. You may need to evaluate the function like something like f of 2. What does that mean? Class, what's your x value here? Your x value is 2. And then if you go up here, or you can just think in your head, put your finger at where 2 is. Your choices are blue, red, or green. Can 2 be smaller than -1? So no, it's not the blue. Is 2 between -1 and 1? No. Is 2 bigger than or equal to 1? Yeah, so to evaluate 2, I can put in here. So 2 squared is And I already know that. Look, 2, 4. Does that make sense? So if you ever have to evaluate it, you just have to pick one of these. It's kind of like multiple choice. So our answer would be 4. So how to graph piecewise functions? Draw your boundary, graph, erase, and then evaluate it.